Next, we have Coulomb's law. Coulomb's law states that the magnitude of the electric force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Using formula, we have F equals K times the absolute value of the product of the two charges divided by the square of their distances. So if you have point charges, okay, kung isa positive, isa negative, or both pareha sila kuan sign sa charge, then most likely they will be repelled by each other or attracted to each other, depende sa ilang charges. And the magnitude of the force is measured by this law, Coulomb's law. Accordingly, the magnitude of the force is directly proportional, meaning pag mas dako ang charge, mas dako ang force. Directly proportional sa charges ha, duha ka charges, point charges, and inversely proportional to the square of its distance. Meaning, pag magkalayo ang duha ka charges, magkahina ang forces. Pag magkaduol ang duha ka charges, magkakusog ang force. And take note that this formula is only applicable to point charges. Because if naatay bola, dako nga bola, either positively or negatively charged, then lahi ang formula na ato ang gamiton. This formula cannot be used. And the value of K is measured as 8.988 times 10 to the minus 9 newtons meter squared per coulomb squared. In some books, this value is rounded to just 9.0. Okay, but sa atua lang gamito ng yang 4 significant figures na value. 8.988 times 10 to the 9. However, this formula is derived from the following formula, wherein ang K, the constant there, is actually a shorthand or shortcut nga pagsulat sa more technical term na 1 over 4 pi E naught. Ang pagbasaan is E naught or E0. Epsilon naught or epsilon 0. And ang tawag aning epsilon naught or epsilon 0 is the electric constant. And the value of epsilon naught is 8.854 times 10 to the minus 12 coulomb squared per Newton meter squared. Like with some laws concerning forces, Coulomb's law is also subjected to or affected by the principle of superposition of forces. Ana diri that if you have a force 1 due to one charge and a force 2 due to another charge, then force 1 is independently affected by the presence of force 2, and also ang force 2 is not affected because of the presence of F1. And the net forces of these forces on the third charge is equal to the vector sum of the two forces. Like sa Newtonian mechanics, when you have many forces acting on an object, the net force is the vector sum of that many forces. And this is similar sa Coulomb's law. Okay, let's have our first example. 2-point charges, Q1 is equal to 25 nanocoulombs and Q2 is negative 75 nanocoulombs, are separated by a distance of 3 centimeters. Find the magnitude and direction of the electric force that the charge 1 exerts on charge 2, and B, that charge 2 exerts on charge 1. So we will use the formula by Coulomb's law. F1 on 2 is equal to 1 over 4 pi E naught times Q1 Q2 over R squared. So, kanang term nga 1 over 4 pi epsilon 0, you will just make it as 8.988 times 10 to the minus 9. Kay mura man ang gyapo ng K, no? The K is equal to that expression. You multiply that to the charges, to the given charges, 25 times 10 to the minus 9, because nano means times 10 to the minus 9, and negative 75 times 10 to the minus 9. And this understood nga in coulombs ni siya, because the standard standard unit for charge is coulombs, divided by 0.03. 0.03 because ang kanang 3 cm imo pa na i-convert into meters, because cm is not standard unit. Meters is the standard unit. So you have to convert it to meters. So 3 cm becomes 0.03 meters. Then you square it, you calculate it, and you will get 0.019 newtons. Next, part B, charge 2 exerts on charge 1. By the principle or by Newton's third law of motion, pag naatay force exerted on one object, then that object also exerts the same amount of force. The same magnitude but in opposite direction lamang. So, kung unsa ang force nga exerted by charge 1 to charge 2, that force is the same exerted by charge 2 to charge 1. So, same lang gyapon sila, 0.019 newtons. Same magnitude, but it could be that the force 1 is going to the right and the force 2 is going to the left. Now, let's have many point charges on a line. 2 point charges are located on the x-axis of a coordinate system. Charge 1 is 1 nanocoulomb, is at 2 cm, x equals 2 cm, mo niyang coordinate. And charge 2 is negative 3 nanocoulombs at x equals positive 4 cm. What is the total electric force exerted by charge 1 and charge 2 on a charge 3, which is 5 nanocoulombs at x equals 0? If daghan na gani taog charges involved, then it is very recommended to draw so that you will visualize the situation. So you have sa x-axis naatay charge 1 at 2, charge 2 at 4 cm, and charge 3 at 0 at the origin. Okay? Ang ginapangita man diri is the total electric force exerted on charge 3, Q3. So we will first get the force exerted by charge 1 to charge 3, that is F1 on 3. And using the formula, 1 over 4 pi epsilon 0, that is 8.988 times 10 to the minus 9. At walang sa i-omit ang units para dili kayo mo taas ang calculations, but we should be reminded that the units used in all of our calculations dapat naka-standardized. SI. Otherwise, mali gyud ang imuhang answer. Q1 is 1 times 10 to the minus 9 because nanocoulombs. Q3 is 5 times 10 to the minus 9, then divided by 0.02 meters. Then you square it. I-calculate ni muna, you will get minus 1.12 times 10 to the minus 4 newtons. Now, question is, nga nung negative? In fact, sa atong formula, we use the absolute value. And absolute value, dapat, kuan man na siya, always positive. Well, imo na siyang tan-awon dito sa diagram. Imo i-consider, asa man padulang imong force? To the right. If it is going to the right, you make it positive. Or to the left, kay kung to the left siya, you make it negative. Now, Q1 is positive, and Q3 is positive. And we know that pag naay duha ka positive charges, mo repel. They will repel each other. Q1 will go to the right, while Q3 will go to the left. And we are concerned with Q3, so ang Q3 is going to the left, then the sign of your force is negative. That's why negative na diha. Next, charge 2 on charge 3. So F2 on 3. And using the same formula, your K is 8.988 times 10 to the minus 9. Q2 is minus 3 times 10 to the minus 9. Q3 is the same, 5 times 10 to the minus 9. You divide it by the distance. Now, dili na siya 2 cm, but 4 cm, so 0.04 meters. You square it, you calculate it, you will get 8.43 times 10 to the minus 5 newtons. So here, you see that Q2 is negative and Q3 is positive. And we know, pag unlike signs, they will attract each other. So, ang Q2 will go to the left, while Q3 will go to the right. So, ang Q3 ang atong concern, it goes to the right. So, this force is positive. Positive 8.43 times 10 to the minus 5. And the total force exerted on charge 3 is the vector sum of these two forces. So you add it considering its signs. So negative 1.12 times 10 to the minus 4 plus 8.43 times 10 to the minus 5. You will get negative 2.77 times 10 to the minus 5 newtons.